Hi guys! For today, we're going to solve the sample problems included in our handout. Okay, so for problem 1, the figure shows a 2-inch diameter solid steel cylinder that is built into the support at C and subjected to the torques T sub A and T sub B. Okay, first, determine the maximum shear stresses in segments AB and BC of the cylinder, and number 2, compute the angle of rotation of end A. Use the modulus of rigidity G to be equal to 12 times 10 raised to 6 psi for steel. Okay, so this is our figure. Okay, so naka 3D siya, no? You have a counterclockwise torque at A, a clockwise torque at B. Okay? Now, referring to the right-hand rule, tingnan natin yung torque at A. Okay, di ba? Kapag in-apply mo yung right-hand rule, yung thumb mo will be directed to the right, no? Kaya yung naging equivalent illustration natin dito sa 2D, okay, at point A, you have a double-headed arrow, okay, to the right, and it said 900 pound-foot. Guys, kapag double-headed arrow, ibig sabihin yan ay torque. Kapag isa lang yung arrow, that is a force, no? So, a force is different from a torque. Okay, so, again, kapag 2D, yung illustration natin for torque is a double-headed arrow. Okay? And then, ito namang 400 pound-foot na torque at B. So, applying the right-hand rule, yung thumb mo will point in this direction, di ba? Kaya, dito sa illustration natin, meron tayong double-headed arrow pointing sa left, no? To the left. Alright, so this is our figure. So, ito yung given. O guys, kayo din, you write the given, the required, and then your solution. Okay, so for the required, we are to find the maximum shear stresses, torsional shear stress kay AB at kay BC, and the angle of twist at A. Okay? Theta at A. So, anong una natin gagawin? Let's consider cutting segment AB. Dito, cut tayo, diba? You can choose to what do you call this? You can choose the left side or the right side of your figure. Ako, I chose the right side. Okay. You have at A 900 torque to the right. So, para maging in equilibrium yung figure natin, kasi in equilibrium yung body dapat dito in equilibrium din. Dapat may magbabalance sa 900 pound-foot. So, paano yun mababalance? Siyempre, kailangan meron kang to the left na 900 din. Okay? So, ito na yung torque AB natin. Okay? 900 pound-foot. Ngayon, let's apply this sa formula na, di ba, yung maximum, sabi sa lecture, maximum torsional shear stress is given by TR over J. Substituting the formula for J, we have this. Okay, so substitute lang tayo 900 over 16 times 900 over pi times 2 raised to 3. Okay. You might get a different answer. Why? Kasi yung 900, hindi mo kinonvert. Itong 900 na to, this is in pound-foot. Itong 2 na to, this is in inches. So, yung 900 mo, dapat times 12 mo. Pag ginawa mo yon, ito yung makukuha mong sagot. 6,875.494 psi. Okay? So, ito yung answer natin for AB. Tau max kay AB. Now, let's try cutting segment BC. Dito naman. Alright? If you cut kay segment BC, you will also have to balance the torques. No? Ano yung magbabalance? You have 900 to the right, 400 to the left. So, anong kulang? dapat meron kang 500 to the left din. Alright? So, yung 500 pound-foot, siya na yung torque BC. Okay? So, ganun ulit. You use the equation, and then, upon solving, you will get maximum shear stress for BC to be equal to 3,819.719 PSI. Okay? And then, last is to compute for the angle of rotation at A. Oh, guys. Yung cross-section at A is free. Diba? Free end yan. Tapos, yung B, walang restriction. Yung C, naka-fixed. Okay? Meaning, yung C, hindi talaga yan mag-move kahit anong ikot ang gawin mo dito. Kahit anong twist. Okay? So, guys, let us remember, ano nga ba yung formula ng theta? Theta is equal to TL over JG. Okay? And then, sabi dyan, guys, theta A. So, rotation at A is equal to theta A over B plus theta B over C. What does it mean? Theta, yung A over B, ibig sabihin yan, rotation of A with respect to B. Okay? Diba may torque tayo dito? May twisting moment tayo dito. So, yung magiging rotation, theta A over B, rotation of point A with respect to point B. Okay? Ito lang yon. Tapos, dahil may moment din tayo dito, may torque tayo dito, magkakaroon ka ng rotation of B with respect to C. Nakuha nyo, guys? And yung overall total rotation of A is equal to the sum of these two angle of twists. Okay? Kaya naging ganito. Okay? So, ayan. Dito, guys, pinakita ko na nag-times 12 dito sa torque kasi naka-pound-foot. Nag-times 12 dito sa length kasi naka-feet. Okay? So, upon solving, yung theta A natin is 0.04584 radians. Guys, always remember, ang masosolve mo laging theta ay radians. Okay? You have to convert it para maging degrees. No? So, upon conversion, theta A is equal to 2.626 degrees. So, this is our final answer. Okay? So, ito guys, these are our final answers. No? And for this problem. Okay, so we're done with problem 1. Next, we have problem 2. The shaft consists of a 3-inch diameter aluminum segment that is rigidly joined to a 2-inch diameter steel segment. The ends of the shaft are attached to rigid supports. Calculate the maximum shear stress developed in each segment when the torque T equal to 10 kip-inch is applied. Use G equal to 4 times 10 raised to 6 psi for aluminum and 12 times 10 raised to 6 psi for steel. Ayan. Kanina guys, iisa lang yung material. Diba? Steel lang. Ngayon, dalawa na. Meron ng steel, meron pang aluminum. And this time, naka-fixed yung ends ng ating shafts. Okay? Tapos, sabi, rigidly joined si steel kay aluminum. Alright? So, yun yung sabi sa problem. Now, let's write the given. Let's express this figure in terms of 2D. So, yung counterclockwise torque is a torque na directed to the right. no? From right-hand rule. Ayan. Okay? So, yung T daw is 10 kip inch. Tapos, these are the other given information. Rigid supports. T is this. G ng aluminum, G ng steel. Right? And what is required of us? To find the maximum torsional shear stress kay aluminum at kay steel. Okay? So, paano natin gagawin yun? So, first, let's cut to show the internal forces. Cut sections. Putulin mo dito. Putulin mo din dito. So, upon doing that, you will expose yung torque kay aluminum and yung torque kay steel. Okay? Oh, guys, hindi natin alam yung values ni torque, aluminum, torque, steel. Kaya, yung direction na yan, ano ko lang yan, assumption ko lang yan. Okay, so kayo, pwede rin kayong mag-assume. Gusto mo, assume mo to the right. Okay lang. Okay? In-assume ko lang na to the left. Para i-contra niya yung 10 kip inch na to the right. Pero, I am not sure kung yung assumption ko ay correct. Okay, so, again, assumption lang yung direction natin. For now. So, what's next? Next, we have to some moments about X. Okay, so, ano yung X pala, guys? X is yung ito, yung X-axis natin. Okay. Kasi, dun iikot eh, di ba? Ito yung X-axis. Ayan. Diyan, iikot yung mga torque natin. No? So, dahil yung problem natin ay in equilibrium, meaning, yung summation ng moment should be 0. Diba? Okay, so, yan. Sum na tayo ng moments. Yung 10 pound, 10 times 10 raised to 3, kasi 10 kips, no? So, 10,000 pound inch. This is to the right. I am assuming na yung to the right is positive, to the left is negative. So, positive to. Minus torque aluminum, kasi siya ay inassume kong to the left. Minus torque ni steel, dahil inassume kong to the left din siya. Equals 0. Now, because of this, we were able to arrive at this equation. No? Na si T aluminum is equal to 10,000 pound inch minus torque ni steel. Okay, so this is our first working equation. Ayan. Since, by the way guys, ito ay example ng statically indeterminate problem. Diba? Kasi isa lang yung equation natin eh. Equation ng equilibrium, isa lang oh. Magsasum ka lang ng moment. Wala ka namang isasum na forces eh. So, isa lang yung, pag-generate mong equation. But then, ang unknown ay dalawa. Okay? So, kaya hahanap tayo ng compatibility equation. Nandun yun sa lecture. Okay, so this is it. Yung example. So, since the steel shaft is rigidly attached to the aluminum shaft, the angle of twist will be equal for both materials. Ito guys, dapat, marunong kang mag-analyze ng problem. Kasi sabi sa problem, di ba, rigidly joined. Pag sinabing rigidly joined, kung ano yung magiging angle of twist ng isa, yun din yung angle of twist ng kabila. Therefore, equation yun. Diba? Oh, angle of twist is equal to TL over JG. Since rigidly attached, yung theta ni aluminum equal sa theta ni steel. That is another equation, diba? So, ito ang tinatawag na compatibility equation. Okay, ganyan. So, we are just substituting values. Okay, we now have two equations, two unknowns. Thus, we can solve for the values of T aluminum and T steel. Okay, upon solving, you will arrive at these two values. Ano bang hinahanap? tau max ni aluminum, tau max ni steel. Alright? So, applying the formula, kasi ito ay solid shaft, sabi, solid. Wala naman sinabing hollow, so solid yan. So, ayun, you just substitute the values dito, you will arrive at these values for tau. No? So, yung maximum torsional shear stress for aluminum is 863.213 psi. For steel, that is 3,452.853 psi. So, ito yung ating final answers. Okay? So, ganito guys, yung compatibility equation. Okay? Next, we have this problem. So, meron na tayong thin-walled tube. A steel tube with a cross-section shown carries a torque P. The tube is 6 feet long and has a constant wall thickness of 3/8 of an inch. Number 1, compute the torsional stiffness K. So, K is equal to T over theta of your tube. Number 2, if the tube is twisted through 0.5 degree, determine the shear stress in the wall of the tube. Use G equal to 12 times 10 raised to 6 psi and neglect stress concentrations at the corners. Kasi guys, pag ganito, mataas yung shear, yung stresses dito sa mga kanto. No? Doon sila naiipon. Parang ganon. Pero, for this example, we are to neglect that information. Okay, so given, first let's write a given. We just copy yung figure. And then you write yung additional information. L equal to 6 feet, theta is 0.5 degree, G is 12 times 10 raised to 6, psi. So, ano yung required? Torsional stiffness K and yung shear stress. Okay, so how are we going to solve? First, let us write the equation for theta. Yung theta natin, kapag thin-walled tube, diba? Nasa, lecture, TLS over 4G A0 squared T. May T yun, guys. May T dapat yon. Wala lang sa lecture, pero may T dapat. May T dapat yan. Yan. Okay? So, sabi, K is equal to torque over theta. Why not substitute theta dito? So, if we do that, yung torque will cancel out. No? So, you'd be left with K equal to 4G A0 squared T over LS. Okay? Yan. So, tingnan mo. G, given. A0, hindi given. L, given. S, S guys ay yung ito yung perimeter. Hindi ko pala nasabi. Ito yung perimeter. Perimeter nung center ng thin wall tube. Alright? So, let's solve for A0. So, si A0 is area enclosed by yung gitna ng thin wall tube. Okay? Guys, kung mapapansin mo, yung dimensions, nandun siya sa gitna, hindi dulo-dulo nung ayan, kung mapapansin mo, yung given na dimensions ay nasa gitna ng thickness, diba? Nung ating thin wall. Hindi naman dulo-dulo. So, ibig sabihin, kung ano yung masosolve mong area dyan, yun na yung area ng A0. Okay, pero syempre, kung ang given sa'yo, yung dulo-dulo, magma-minus ka dyan ng, alam mo na, thickness over 2, diba? Alright? Right? Dito, minus ka dito, dito, minus. Pero para mapadali ang buhay, ngayon, ang example natin, ganyan lang. So, medyo direct substitution. Okay? Ayan. So, to solve for A0, this is just a, anong tawag dito? Trapezoid. Ayan. Okay, so trapezoidal yung, yung thin-walled natin. So, to solve for that, diba, that is just base 1 plus base 2 over 2 times yung leg. Okay, yung height times yung height. Kaya, meron tayong 6 plus 4 divided by 2 times 5. Okay, so yun yung area ng ating trapezoid. So, you'll have A0 to be equal to 25 inch squared. Alright? Next is to solve for S. S is the perimeter of the, of the gitna, no? Yung gitna ng thin-walled mo. So, you just sum. You just take the sum. So, it's 6 plus 4 plus, ito ay hypotenuse, diba? Hypotenuse lang naman ng triangle. Ano yung leg dito? This is 1 inch. Kasi 1 inch plus 4 plus 1 inch, that is 6. Alright? So, square root ng 1 squared plus 5 squared. Okay? Kaya yun yan. Okay. So, ayun. Times 2 kasi syempre dalawa. 1, 2. There you go. So, perimeter natin is 20.198 inches. Okay? O, pwede na nating isolve yung K. Diba? Pwede na tayong mag-direct substitution. Ayan. 4 times G times A times thickness over length. Length is in feet. That's why we multiply it by 12 para maging inches times yung perimeter S. Okay, so you'll get this value. This is 7,735,914 pound-inch per rad. Okay? Again, so may radians ka dyan. Convert natin, gawin natin degrees. You'll have K to be equal to 135,017.18 pound-inch per degree. So, this is our first answer. Alright? Next. Tau. Tau yung requirement. Okay? So, paano yun? Wala pa tayong pang-solve sa tau eh. Solve muna natin yung torque. Okay? Diba? Sabi sa ayan. Okay. So, sabi sa lecture, diba? No. Diba dito, torque is equal to, K is equal to torque over theta. Given yung theta, na-solve na natin yung K, we can now solve for torque T. Ayan. So, you just multiply this value by 0.5 degree. So, you'll have this, 67,508.589 pound-inch, as your torque. Now, substituting this value, doon sa formula natin ng shear flow, you remember shear flow is denoted by Q. Q is equal to T over 2 times A0. Okay, substituting values, you'll have shear flow to be equal to 1,350.172 pound per inch. Ayan. Dahil meron ka ng shear flow, pwede ka nang makasolve ng shear stress. Okay? So, yung ating torsional shear stress for thin-walled tube is equal to shear flow over the thickness. O, substitute mo ng value ng shear flow. Tapos, yung thickness natin na 3/8 of an inch. You'll have tau to be equal to 3,600.458 psi. So, ayun na yun. Ito na yung final answers natin. Alright? So, that's it. We're done with this problem. So, that's it, guys. Thank you.